Hi, I'm Anna Tapper, and welcome to this bite-sized session on using numberless word problems to develop pupils' reasoning. This is part of the spring term CPD programme for 2023. We know that the hardest part of problem solving is understanding the context and knowing what to do. Once this is explained, most children are then able to apply the arithmetic procedures needed to find a solution. Using numberless problems is a great way to focus in on the why rather than the how. If we look at these stages of problem solving, most children rush over the first two stages and focus on the execution of their planned operation. By removing numbers, we ensure their attention is directed towards exploring and understanding initially. Let's start by looking at this question to explore that notion a bit further. What do you think the most common incorrect answer would be and why? If you're working with colleagues, please pause the video here to discuss. Most pupils who answer incorrectly state 8 because they've simply looked at the numbers, seen the word altogether, so have added them. If I rewrite this problem without numbers, suddenly the context is more prominent. So stage 1. I want them to explore that context. Some children will automatically try to assign numbers to the amount of cars. However, refrain from this initially. Ask them what's known and what is unknown. You might ask them to represent it in some way. That could be by drawing cars or something that stands for cars. Could they draw it as a bar model and make their drawing more mathematical? In stage 2, you add one value in. If we add a value to the amount of cars that Hector has, 3, then what is known and what is unknown now? Can you draw this? By slowly building up to adding values to the problem, we are starting to explore the mathematical understanding within it. Stage 3 is to add all the values in and to solve the question. This may seem like a long way to teach problem solving. However, if we focus on the numbers and what to do with them, then we're simply focusing on the arithmetic procedure rather than mathematical understanding. Children will then find it difficult to transfer this learning to other problems if they've not explored the deep structure of the question. So let's look at a more challenging question. This one is from the latest round of Pixel assessments in Year 5, and only 36% of pupils answered it correctly across the trust. You may want to pause the video and consider why this is. Where might the lack of understanding be? Now consider what's known and unknown. Ask how you might represent this. Can their drawing be made more mathematical? Many children may struggle to represent this information in a drawing, so can they picture it in their heads? A quantity of computers are being put into equal groups in boxes. Now, can they think how that could be represented? Careful thought has to be given to which value you reveal first in this question. Revealing how many computers are packed in each box starts to give some structure, as they now know we are working with equal groups of 8. Reveal the second value and ask children to imagine putting the computers in the boxes in groups of 8. What is this process known as? Developing their understanding should lead to a recognition that the question is asking them to divide. If you really want to create a high-thinking, low-jeopardy approach to problem solving, use a numberless problems gradual reveal approach, but make the final reveal the answer. This ensures that pupil attention is focused on reasoning and thinking hard rather than calculating. It's a great way to be fully inclusive and ensure that those higher attaining pupils who are in a race with each other to find the correct answer are forced to slow down and explain their thinking. We all know the answer, but how do we get there? Giving children lots of numberless questions like this in a different context where rounding is an important factor will support them to understand when to round up and when to round down. Here's another example for you to try. Notice and jot down what your attention is drawn to when the problem does not have numbers and cannot be solved. Initially, I noticed the key terminology of fraction in the question. What fraction of the window is green? This gives me enough mathematical understanding to make meaning from the question. I would then think about what the different colours represent. They're all parts, and the window is the whole. They could be equal parts with the same denominator, or they could be equal parts with an equivalent denominator. They could also be unequal parts. I might draw a window shape, or I might draw a part whole model, perhaps a bar model. This will help to expose the structure of the problem, the two parts that are known and the one that is unknown. To find the value of the unknown parts, I need to add the value of the known parts and subtract this from the whole. Developing this mathematical talk with your class will support them to identify strategies to use when they don't know what to do. The easiest thing about this approach is that you do not need a special bank of numberless problems to use, as you simply remove numbers from any given problem and replace it with words or a blank space. And the best thing about this approach is the rich mathematical discussions that your class will engage with. They'll be thinking deeper, be forced to slow down, and recognise that maths isn't really about quickly finding an answer to a calculation. Pixel have a whole section on using numberless word problems called number and answer free zones. Once pupils have discussed and understood the context of the problem, it is easier for them to identify the structure within it. The final stage in this approach is to present the same problem, but with different numbers, so children can demonstrate their understanding. Here are some next steps for you to consider. Think about the scheme of work you use and how you could adapt problems to turn them into numberless problems. Plan to give additional time to the process to allow for deep mathematical thinking to develop. Do not be discouraged if your pupils are not receptive to this approach initially. It takes time to build the expectations, and you will need to model lots of mathematical thinking yourself to begin with. Try partnering up with another teacher to plan a numberless problem and arrange a time to meet again to discuss the successes and challenges. I look forward to hearing how you get on.